Hello, my name is Kevin Pearies. I'm a Senior Applications Engineer with EXFO. And today I'm going to be talking about something that I think we all strive for, and that is workflow efficiency. So what do I mean by workflow efficiency, and what does that have to do with testing? And so, quite frankly, much of the activity that we look at as far as testing goes has always really been quite manual. And so, it's a bit ironic that we're putting in fiber optic lines, we're putting in higher speed capacities and bandwidths to provide more services, but we're not always taking full advantage of those services that we are helping to build. And so this is part of what I wanted to speak about today. So as a technician, a lot of what I try to do is I try to be more efficient, right? I tried to get more done with the tools that I had within the time that I had, right? For a lot of different reasons, right? For budgetary reasons, for, meeting, job statuses and completion dates and those types of things, right? And there's a lot of metrics that are measured based around these types of activities. How far along during the construction project are we at? Those types of things. And unfortunately, we spend a lot of time doing a lot of manual labor, right? Whether it's administrative or physical, when we don't always need to. And so from a testing perspective, I'm going to give kind of one example of workflow efficiency that kind of merges a lot of the legacy type of testing that we're doing, along with taking advantage of some of the newer cloud-based systems and, these types of services where you can deliver information quickly, right? Because we are delivering information across the globe quite a bit quicker. So why can I not get my test results from my machine into the hands of somebody to evaluate and report in a much timelier manner? So I'm going to be talking about fiber characterization and how I would look at fiber characterization to increase workflow efficiency. So when I was a technician years ago, I used to work on the railroad right-of-way. And I talk about this a lot because it really did shape a lot of the way that I think when it comes to just the way that I work. And so working on the railroad right away, anytime we had to work on our communication systems, at that time for me it was fiber optics, if we were within a certain amount of distance of the track, we call it fouling the track, we had to call the railroad, set up some permitting, get track in time, shut down the train so we can go repair our infrastructure. This is not something they like to do. And so we really had to get in and out of there very quickly. So there was a lot of tips that I learned while I was testing to speed that up. And we'll talk a little bit about some of that, right? Just like anything that we do, whether we're a mechanic, whether we do woodworking, anything that we do, sitting in front of a computer and taking advantage of hotkeys and macros and those types of things really helps our efficiency. So from a test perspective, we'll talk about some of the things that I think you might find interesting. So when we're talking about fiber characterization, what kind of testing are we talking about, right? And so from a very high level, we're talking about OTDR testing or iOLM, which is our version of an advanced OTDR. And I'm oversimplifying that, but that's essentially what it is, right? And so OTDR iOLM, and this test for full fiber characterization is something that is done bidirectionally. Right, so this is a bidirectional test, and so you're looking at A to B and B to A, and so you have a far end location you're testing to, right? And then we have OLTS testing. So OLTS is kind of it's a generic term, optical loss test set. Usually when I talk about that as it relates to fiber characterization, I'm talking about doing span loss, so end-to-end loss, and ORL. Optical return loss, right, which is kind of span reflection. So the overall quality of that fiber optic line. And then the last test, more advanced optics, is CD and PMD. This is dispersion testing, so chromatic dispersion and polarized mode dispersion. So the intention of this presentation isn't necessarily to go into the details of these different testing, but this is the kind of test that we do for full fiber characterization. And so how does this relate to workforce efficiency? Well, there's a lot of things that you can look at when it comes to testing, right? To speed up your testing to be able to maintain the quality, and not only the quality of the work being performed, but also the quality of the results that are being delivered to your customer, whether internally or externally, right? So one of the things that we can do to really help with efficiency is to kind of streamline the test process. And so having the flexibility to what I call decouple testing is incredibly important. And one reason I like to explain it or talk about this at length is, when I used to splice, say that I was splicing between two different locations, and this could be 50 miles, this could be, 5 kilometers, whatever it happens to be. So we have a length of fiber or some sort of cable I need to work on, right? And so if for some reason we unfortunately had a cut and had to repair this fiber, we would send out splicers, we would send out testers to repair this break, right? And so, for instance, if we had to do what we called a section throw at that time, basically create 2 splices within the same location because we didn't have enough slack to join those 2 pieces together at the break, right? And so when we did that, we would essentially have 2 splices very close to each other, usually within 100 feet or so, right? So, we'd have a section throw about 100 feet. And so now you have 2 splicers, right? So you have 2 splicers typically, and you want 2 splicers because you need to get this thing done quick, right? After all, it is a break. So you have 2 splicers, 1 in each pit. And admittedly, I wasn't the best splicer. I wasn't very fast. My quality was good, but my speed was not, right? And so often enough, I would fall behind. So I would be 1 or 2 or 3 ribbons back from the other pit. The downside is there's no testing that can happen. So if you have testers on either end here that are waiting to do your iOLM test, that are waiting to do the qualification of the fibers, they would have to wait, right? And usually during an outage, that's 2 technicians because you want to repair this and get your mean time to restore, mean time to repair as low as possible, right? And so you would throw a lot of labor at it to ensure that you met those types of SLAs. And so unfortunately in this case here, nothing can get tested until I was done. And so I was kind of bringing down, the work efficiency, so to speak, right? And this is true with everything that we do. We all have different levels of expertise. We all have different levels of capabilities, right? And we also have other challenges that are outside of our control. And so some of those challenges can really impact the way that you test and the efficiency that you have to complete that test, right? And so another example. So for example, let's say that I have a test that I have to complete between 2 locations, right? And so in this example here, I'm going to talk about full fiber characterization. So this isn't an outage situation. This is new fiber construction stuff. This is qualifying dark fibers. This is verifying SLAs for IRU agreements. This is the full fiber characterization testing that I mentioned earlier, right? And so for EXFO, we have different solutions that will accomplish this testing. And so in this particular example, what I have here on the left is I have the FTB4, which is a 4-slot modular system that we have. And within this 4-slot, I can outfit iOLM or an OTDR, OLTS, CDPMD, so the full fiber characterization test suite. And then on the other end, we have over here a more portable FTB1, which is also modular. So the modules can go back and forth between the 2 units. It has iOLM, OTDR, and an OLTS, right? And so we have these solutions on either end. And so, one of the great things about decoupling or having the flexibility for workforce efficiency is that you're able to really have a little bit more flexibility on the way you're testing, right? So for example, we are testing between these 2 locations. And so we're going to have different modules in here. And for, the FTB, we have this FTBX, which is our modular solution that goes into the newer platforms. And our 700 series is essentially our OTDR iOLM unit, right? So this is to really map out the fiber. And then we have a module called a 945, which is our OLTS, which does ORL and loss, right? And then we have a very unique device, the 5700, which does CD and PMD, but it does it single-ended, which is great. We have a double-ended solution for ultra long haul, but this single-ended solution is great. And so when we're talking about efficiency, we're going to tie that into the, kind of the test case, right? And so looking at this right now, this is the testing we're going to do. And on the opposite end here, we're also going to have another, 700 series OTDR and another 945, right? We don't need a CD PMD here because it's only a single-ended test, so we only need it on one end, right? And so this is the testing that I'm going to perform. And so here is one of the challenges that we have, right? And so, for instance, if we were to couple our testing, meaning if we had to set up the test for both technicians to be there at the exact same time, matching the exact same level and speed of testing, we start to add some logistical challenges, right? And so there's several challenges that come into place. One, it is not uncommon for the far end here to have access issues, meaning the far end could be a customer location. It could be a government facility that requires, signing in, logging in, escorting. It might be a high security data center that requires the MOPS and procedures and things to be in place for you to access that location. So, you have to wait for some of that to happen. So that's challenge number one, right? Challenge number two might be something like we talked about earlier with varying levels of expertise. And not just expertise as well, right? They might have different challenges like, in this location here on the far end, on the remote side, this might be a brand new build. What does this mean? This means new FDP, new connectors, new panels, new everything, right? Over on the A side here, so over on the A side, we have a legacy site. So this switch or hub has been here for years. It has old panels. It has ST connectors, right? It has a lot of issues with just years of contamination of these connectors. And so just cleaning and inspecting the connectors on the A side might take quite a bit more time to get the level of performance that you need to qualify for a test. So there's a lot of different levels of challenges here. And so when you tie that into testing, if I was a tester on one side here, let's say on the A side, and then I start testing, right? And I'm going to start testing and everything's going great. My fibers are cleaning good. All my results are good. I don't have to do any retesting. And so if I decouple my testing, I'm going to be testing a lot faster. And so I might be 2 or 3 ribbons in of testing. But the tester on the B side is having more challenges, access challenges. The FDP is elevated, so they have to test from a ladder. I mean, there's all kinds of things that can really slow down your testing as far as challenges, right? And so on that side, they're starting to fall behind. The good news is they're decoupled. And so on the A side, you're running along testing iOLM, and you just keep going. You just keep going. There's no reason, to slow you down. On the far end, they're having some challenges, right? And normally what I would do when I was testing end to end is if we were there at the same time, I would start on fiber 1, and then they would start on fiber, say, 96, and then we would just cross at some point, right? And so I can finish all of my iOLM testing, clean all my panels, everything's going great. And every time I say iOLM, that could be OTDR as well, right? And now I've gone in and I've tested all 96 fibers. I'm done. I don't have to wait for anybody else. I have options now. I can leave to go finish another job that came up. Maybe, there was some emergency that came up, so I can free myself from this project and come back, right? Or even better, I can start testing CD PMD. So now I can launch my 5700, my FTB 5700, and I can start doing single-ended CD PMD, right? CD PMD. And so this is what I mean by decouple testing. And then once I'm finished with this, if there's still challenges here, if this technician hasn't even started because they're having access issues, then you don't have to, sit there and wait for them. You can leave and come back. The only test where you really need to do coupled testing, or where you have to have somebody on the far end or on both sides, is when you're doing OLTS. And so at some point you'll have to schedule that, but you'll do that, at a specific time, right? And you also don't have to, limit yourself to a much larger scope of time because you have to do all of the testing. And so this is what I mean by couple testing, or decouple testing rather, is you're able to test kind of with more flexibility. And as you go through and do this different testing, you'll be able to work much more much more efficient rather. So this is what I'm talking about for some of this. Now, obviously, even within this, there's more levels of streamlining your test flow, right? Understanding and setting up in a certain way, understanding the technology in a certain way, having all the right tools. There's a lot of things that come into play to get as efficient as possible. And even at EXFO, one of the things that we've done is, when you're running an OTDR test, an OTDR test has a bit of expertise involved, right? There's a lot of different settings. You have things like pulse width, you have, which affects range and resolution. You have averaging time for cleaning up noise. You have, range. You have, a lot of different parameters to look at. And when you set these up, you're only setting them up in one perspective, right? Either optimized for a long shot, optimized for a short shot, right? That type of thing. And so even more efficiency is, we often see a lot of issues with test results being set up improperly. So when I was working for a tier 1 provider, I was on disaster recovery, and every once in a while I'd be on one of those bridge calls, one of those silent voices in the back. And I would sit there until somebody on the bridge said, who here is on call for helping with testing, right? And OTDR testing specifically. Because if we get a technician on there that didn't fully understand how to interpret the results or to set it up, then I would help walk them through that process, right? Because it can be very complex. So iOLM is another way to do efficiency because it automates a lot of that. And it adds an incredible amount of intelligence with algorithms, that really interpret the fiber. So you don't worry about a lot of those settings. You load a configuration and you hit start. To a very large degree, that's all you do. So even more efficiency. And so we're improving our efficiency more and more because quite frankly, that's what we're going to have to do because if you think about it, the cost per bits, this is something that a lot of executives thinks about, right? The cost per bits. And so, and what we mean by that is the cost to deliver bandwidth. There was a time when I worked on a T1, you're looking at $4,000 or more a month for the cost of a T1, depending on the types of services, the distance, et cetera, right? And a T1 is only 1.5 megabits per second, right? And back then, that's a lot of bandwidth. But it was primarily just voice calls, right? A lot of the providers made their money on long distance at that time. Nowadays, 1.5 megabits is not enough. It's not even enough for me to stream this as a video, right? Not efficiently. And so the cost per bits has started to drop. So as the customers demand more bandwidth, the cost has come down, right? There's more competition. And so it's really important to increase your efficiency. And this is, one way to do it when we're talking about testing, right? And so obviously there's a lot of other ways to reduce efficiency, but this is testing. And so when you tie all these things together, it really benefits yourself and the company that you work for, right? And so having the ability to be able to test independently and efficiently is very important. There's one more aspect, right? And so now we're starting to test. When we're testing with iOLM or OTDRs, the results that we look at really are bidirectional, so the averaging. So when we're looking at the results, we're going to have an A to B loss. We're going to have a B to A loss, right? And so we're going to have, this information available to us. But at the same time, individual loss and, based on the technology and the way it works, we're really more concerned about the average loss bidirectionally. And of course, if you only test in one direction, you don't know what the other direction looks like, right? And so this is some of the challenges that you have as well. And so we have, utilizing some of the cloud-based infrastructure that I mentioned in the opening, we're really able to get the data from the field in a much more efficient and real-time manner, not only to the technician on the far end, but also to an engineer that's sitting in a building 1,000 miles away, right? So we have that kind of flexibility. And so So I'm going to go over, utilizing some of this, because our platform, the FTB2 and the FTB4, along with the FTB1 Pro, are fully functional Windows 10 operating systems. So, and they have quite a bit of processing power, right? So you can literally run Photoshop on these if you wanted to. And so with that, you have a lot of flexibility for third-party software. You have a lot of flexibility in installing applications that are unique to your organization. And one of the things you can do is you can install cloud-based syncing devices like folders and whatnot. So, we're talking about things like, Dropbox, SharePoint, which is a big one for many of us, right? Google Drive. And so there's a lot of different ways to save and communicate data. You can email it. You can do shared drives. You can Bluetooth it. You can Wi-Fi it. There's a lot of different ways to get data off. Just think about all the ways you get data off of your PC today. We can do the same thing to a very large degree. And so I'm going to kind of show that, to close off work efficiency. And so here's what I've done. I am VNC'd into a test set. Because we are a Windows 10 platform, VNC is just one of many ways that we can remotely control the platform itself or the test set itself. So VNC server does come on the test equipment. You can also install third-party programs. So if your company uses a unique licensed device, or if you've developed something in-house for remote connectivity, you can support that as well. And another interesting thing is Windows developed or actually replaced their remote desktop protocol with an application that they call Quick Assist. So if you type in Quick Assist, and this is for any Windows 10 device, whether it is the test set or if it's my platform, and so or my PC. So if I go over to my PC here, I can do the same thing, right? I can go in here, within my PC, and then I can look for Quick Assist as well, right? So I can type in there Quick Assist, and there it is, right? And so Quick Assist is like a team viewer-like application. So essentially you get a code and you share this code. The end user will type it in, and then you can remotely control it, right? And so this comes with all Windows 10, whether it's PC or in the test set itself. So with that, I'm going to go ahead and launch iOLM. And as I mentioned earlier, iOLM is our version of Advanced Intelligent OTDR, right? We do a whole seminar series on iOLM versus OTDR and the differences in technologies. That's really not the purpose of this session. What I'm going to do is I'm just going to save some traces and show you how we can instantly or near instantly share data across the cloud to that far end user, as I mentioned. So essentially in this case here, I'm going to make sure that I save my test data to a shared drive. And so in this instance, I have a Google Drive that I can share to. And then on my PC, I also have a Google Drive. And I can have Google Drive on the far end platform as well. And I'm just using Google Drive as an example. It could be Dropbox, it could be SharePoint, it could be a network drive, whatever tools that you can use to share will support it with Windows 10, right? And so in this case here, I'm just going to do a quick test. I'm going to do a quick start test and then let it run its course, right? I'm going to show you an application that we have called Fast Reporter 3. We also have a version called Fast Reporter 2 that will also do this. So Fast Reporter is our advanced reporting tool that allows you to create custom reports. And so if you have custom reports within your company that we need to match, we can do that as well, right? In this particular instance, what I've done is I'm going to use it to manage and analyze the data in real time as it streams across the cloud. So I'm going to get in here and make sure that I have something called auto refresh. And so here we have this auto refresh, and I can save or have it refresh into a specific drive. So in this case, it's going to be my Google Drive. So I'll hit apply and hit OK. If there's anything in that drive, it'll automatically pull into this advanced reporting tool, right? So it'll automatically pull into the advanced reporting tool. And so as we complete each of our tests and save them, we can sync this information across the cloud to the far end test set or 1,000 miles away to somebody who's looking at the quality of fiber, right? Or doing analysis for you. And so in this case here, if we go back to the VNC, we've completed the test, all right? So we've completed the test for the iOLM. I'm going to go ahead and hit save, and this will save to that Google Drive. And then as soon as Google syncs, and you see it's starting to sync here, as soon as it syncs into the cloud, depending on the timers that I have set up for Fast Reporter, as soon as that file is complete, it'll pull into Fast Reporter, right? It'll pull into Fast Reporter, and then we can analyze that data. And so that's all within the refresh. And Fast Reporter will handle OTDR and iOLM traces, OLTS for span loss and ORL, CD-PMD for dispersion, and fiber inspection. So if you're looking at the end face of your fibers, and we can create custom reports. So you can get in here and create custom reports either in Excel or PDF, right? So all of that is in here. And we have created custom reports for a lot of different companies, right? And so as that data comes in, we'll be able to see it. And there it is. You just saw it come across the screen here. And so this is the test results from the A side, right? And so I am the engineer sitting 1,000 miles away, and this test data shows up as soon as it syncs. And you'll see that this is the same information that we have on the A unit. And so as this tester progresses along and test, we'll start to see more data populate into that field, right? We'll see it from both the A side and the B side, right? So we'll see it from both sides here. And so I'm going to go ahead and remove this, but as this information starts to come in, you'll see that we start to see it populate. Okay, now we're going to fast forward the end of the day. All the testing's complete. So slowly over the course of the day, we were getting test results. They're being analyzed by both testers on far ends to confirm that the distances matched, that they were seeing the same things, that they were able to look at the bidirectional results, particularly for splice loss, all of those things. On top of that, the engineer 1,000 miles away was also getting the same test data. Their supervisor was getting updates and test data to follow the progress, to look at quality, to see how things were progressing, those types of things. And so it's the end of the day, and all the test data has been uploaded. So I'm going to simulate what it would look like. So Google Drive is full with all the bidirectional iOLM traces. The OLTS trace that contains the span loss and ORL, as well as the CD-PMD from the FTB 5700. And so all of this information is populated in there. And of course, we can automatically refresh that. Or we can manually input this data, right? We don't have to sit here all day long and let it auto-refresh. We can come in later on in the day, right? And say, all right, the testing's been going great. I'm going to go back in there and look at it. So here is all of the test data, right? The bidirectional tests in both directions. And so I can sort this in several different ways. I'm going to go ahead and sort it by the type here. So we can separate basically what we're looking at. So we see all of the CD-PMD results here, 1 through 24. We see the OLTS is in here as well, down at the very bottom. And then we see the bidirectional OTDR, the A side and the B side. So to give you an idea what we're looking at here, I'll select one of the OTDR traces, see what it looks like. So that's from the B side. If I were to highlight just the iOLM traces, if there are matching fibers, meaning if it sees both directions, it'll automatically create what we call a virtual bidirectional file. So you'll see here up in the top left, we have 24 fibers. So each one of these is a virtual bidirectional. Fiber 1 all the way through 24. And we can look at each one of these individually to see what they look like. You can get in here and say, what does the launch look like? What does this first reflection look like at 1.5 kilometers? And we can look, kind of scroll down there. So we're looking for greens and reds depending on our thresholds. So we see all this information. I can generate reports. I can generate a report that tells me what has failed and what needs to be fixed, right? I can get in here with our validator and run a validation test. So I can create a custom validation test that goes in there and looks for parameters that are not set right. Right? And so whatever isn't correct will automatically populate, right? We're missing some measurement information. We're missing some, the lengths are not, appropriate. In this example here, I didn't set a custom validation, but you get the idea, right? It goes in there and it looks for changes in the settings and parameters that are missing. I can select all of the traces, every bit of it, and create a custom report. And so I can get in here and we can create you a custom report, or you can use the pre-canned one. So I can use, say, iOLM fiber characterization here, right? And I can give it some sort of a name, you know, example test report, you know, and this one's going to be in Excel. So it'll go in there and it'll generate a report in Excel. And we like Excel because we can do a lot with Excel. Once something's in Excel, we can create macros, we can do pivot tables, we can do a lot of different things, right? And so here's my report. It's all in here. And so we'll see each individual fiber and all of the relevant information. So all of this stuff that we like. The OLTS information, some iOLM information, CDPMD, it's all in here, right? Look at all that information. So all that information's right at our hands instantly. Instantly. You know, if we need to change anything or reanalyze, we can do that within Fast Reporter. And again, we have a lot of different kinds of custom reports. And so that is it in a nutshell. You know, this is basically fiber test efficiency the EXFO way. My name's Kevin Pearies. Thank you very much.